Hey guys, this is Dr. Conklin. I'm here to go through a quick video for you on page 22 on a mid-segment theorem. So if you think about a mid-segment, a mid meaning middle, and then a segment is just a line segment that has a beginning and an end. So a mid-segment, if you could copy this on your notes, connects the midpoints of two sides of a triangle. So, if we look at this triangle, I've created a midpoint here. And we know it's a midpoint if I put little swoops here. And then same thing here. So if I connect those two midpoints, then I have a midsegment. So this piece here, right here, is actually the midsegment in pink. Okay? So we have a great theorem, the midsegment theorem, that tells us that, well, actually, let's read it first, that a midsegment has two really important properties. First, if I take this triangle, I'm just going to move it around a little bit. It doesn't matter if I make it really skinny or really long. Does everyone see that the dashed line here in green and the solid line at the bottom, those lines are always parallel to each other? So a mid-segment is always parallel to its base. That's that part. And then the other property, which we're going to talk more about today, is that the mid-segment, if you look at the segment, the dashed line here is 6, the bottom piece is 12. So the mid-segment is always half the base it's parallel to. And it doesn't matter if I make a really big triangle or a different sized one. I have 11, I have 10 and 5. Those are always the same, okay? And so let's do a couple practice examples. So this is our definition. So let's try a couple. If we look at number 1, if this is 24, I know that half of 24, in New York you can be a new man. Oh, sorry, I forgot to also say that this goes out to my period 5 kids that are obsessed with Hamilton, although I think a lot of people love Hamilton. So that was our musical request for today. Okay, and just check to make sure, does it make sense? Does this segment here, this mid-segment, look shorter than this segment? Definitely, right? At about half. So we can have this go a couple ways. Let's compare here the mid-segment with its base. This is 13.5, so now we're going to go the other direction, multiply by 2. We have 27, and do not forget those centimeters. Okay? If we look at choice B, now I'm throwing in a couple variables for you guys. So, one strategy that we can use is we can start by sort of setting these two pieces equal. Are these equal though? Absolutely not. What do I need to do to make them equal? I need to take the mid-segment and I need to double it. You could also take this 42 and divide it by 2. So 2 times 3 would give 6x, and 42 I'm going to divide, and so here x is 7. Okay, also if we look at example C, because we have right here 2 parallel lines, so I'm going to just sort of extend this. Those don't look super parallel, but they are, I promise. That's our symbol for parallel. This angle here and this angle here, if we think about this has a transversal. Do you guys see how, and if I wanted to, I could almost white those out. Those are actually our friends, the corresponding angles, right? So if we know that x and 6, or x is corresponding with 68, and we have parallel lines, we know that x is also 68 degrees. Okay, let's try number 4 and set it up together. Okay, so again, are these equal, guys? They're not, right? So how do we make these equal? The mid-segment has to be double. All right, Cody wanted me to play. You'll be back. So I'm going to take, and let me just move this a little closer. 2 times 3x is 6x equals x plus 40. Divide by 5, so x equals 8. Now let's just check this. We always know checking is a good idea. What are the lengths of these? So the lengths of the base is going to be x plus 40. So this is going to be 48. Predict to yourself, what should this be? Half of 48, 3 times 8 for 3x is 24. Okay? All right, so I want you guys to try 5 right now, and then I'll show you the answer, and we're going to do 6 and call it a day. So try 5. Empires fall. Oh, 8 again. That's so funny. Perfect. And then this is 16, so we would predict that this would be 32, which it is. Awesome. Okay, now these are often on the regions, so let's make sure we understand what this is asking. DE, oh, there's no D and E. Oh boy. All right, so we have triangle ABC. Let's just put these in, I guess. Okay, so it asks us to find the perimeter of the whole triangle. How are we going to do that? Well, we're going to sort of take our time and highlight this. DE is a mid-segment for AB. So if DE is 10, then that means this has to be 20, right? And if it helps you guys, like, turn your piece of paper so you can see the other side. So let me get rid of these. So now 7 is parallel to this base. So EF is parallel to CA. So twice 7 is going to be 14. All right. And then the last one we'll look at, we have 8 here. This side is parallel, again, because this is a mid-segment. This is going to be twice. So the perimeter is when you add everything up, 14, 16, and 20. And that means altogether we should have 50. Okay. Hope you guys have a great day. And please be in touch with us if we can help at all. And keep the music requests coming. Bye.